The paper of the day is Object Storage on CRAQ, High-throughput chain replication for read-mostly workloads. This paper describes the design, implementation, and evaluation of CRAQ, a distributed object storage system that challenges this inflexible trade-off. Their basic approach, an improvement on chain replication, maintains strong consistency while greatly improving read throughput. By distributing load across all object replicas, CRAQ scales linearly with chain size without increasing consistency coordination. At the same time, it exposes non-committed operation for weaker consistency guarantees when this suffices for some applications, which is especially useful under periods of high system churn. This paper explores additional design and implementation considerations for geo-replicated CRAQ storage across multiple data centers to provide locality optimized operations. They also discuss multi-object atomic updates and multicast optimizations for large object updates. All evaluations in this paper were performed on EmuLab, a control network testbed. Experiments were run using PC3000 type machines, which have 3 GHz processors and 2 GB of RAM. Nodes were connected on a 100 megabit network. For the following tests, unless otherwise specified, they use a chain size of 3 nodes, storing a single object connected together without any added synthetic latency. This setup seeks to better isolate the performance characteristics of single chains. At a high level, they are interested in quantifying the read throughput's benefits from CRAQ's ability to apportion reads. On the flip side, version queries still need to be dispatched to the tail of the dirty objects, so that they are also interested in evaluating asymptotic behavior as the workload mixture changes. They also briefly evaluate CRAQ's optimizations for wide area deployment. Let's look at the contributions of this paper. There are 3 key contributions. First, CRAQ enables any chain node to handle read operations while preserving strong consistency, thus supporting load balancing across all nodes storing an object. Furthermore, when workloads are mostly read, an assumption used in other systems such as Google File System and Memcached, the performance of CRAQ rivals systems offering only eventual consistency. In addition to strong consistency, CRAQ's design naturally supports eventual consistency among read operations for lower latency reads through write contention and degradation to read-only behavior during transient partitions. CRAQ allows applications to specify the maximum staleness acceptable for read operations. Leveraging these load balancing properties, they describe a wide area system design for building CRAQ chains across geographically diverse clusters that preserves strong locality properties. Specifically, reads can be handled either completely by a local cluster or at worst require concise metadata information to be transmitted across the wide area during the times of high write contention. They also present their use of Zookeeper or Paxos-like group membership systems to manage these deployments. Let's talk PS score for this paper. Overall, this paper is an awesome read, so it gets 9 out of 10 on readability. It's 16 pages long, it scores 7 out of 10 on length. It's a research prototype with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is pretty good. It's been adopted in quite a few production systems across big tech companies, so it gets 9 out of 10 on each. Overall PS score is 9 out of 10.